So what I'm going to talk about is an SCR. An SCR stands for silicon controlled rectifiers. It's like a diode. Here's a symbol. It controls from the cathode to the anode from the gate. Instead of a single diode, you've got the gate as well. There's a semiconductor layout of the silicon, positive, negative, P-N, P-N. Every even turns it on. Like here's a diode, P-N. Here's another diode, P-N. Which means it turns on the simplest semiconductor. Get the P-N-P, which turns it off every third, which is a transistor, until it gets a tiny current into the N. And which is a negative, and then it turns it on. And then here's an NPN transistor, which means positive turns it on. And so it's every even turns it on, every odd turns it off. There's 4 layers, so that means it's even. 1 layer more than a transistor, 2 more than a diode. But it works like a diode as it stays on until the gate is touched to the anode. It's really good for resetting circuits, and it resets it when it goes to 0 volts, which means it turns it off. Back off on 0 volts. And it resets it. So basically it creates a cross from here to here, it turns it off. But usually with 0 volts, it's easier to turn it off until it goes back on. Which means it works with AC like a transistor, but with AC, alternate current, which means it resets every time it goes to 0. It's good for different AC circuits, but it's also good for setting and resetting circuits. And what I like to also do is you could take 2 transistors, make it that way, instead of using full silicone or the full 4 layers. You use this way. If you only have transistors, it's a good idea. You just need a PNP and an NPN transistor. And then what this does, there's a PNP silicon layout, NPN layout, cross together as from this, but technically it connects to this, but it's all connected right here, and it creates this. You combine them, which gives us 4 layers. There could be a gate right here, but that would be a negative gate, which means it'd cross from here to here instead of here to here. But that's to shut it off. To turn back on, you need the little volts. So usually with AC, you have a resistor here, and it resets it. It goes down to 0, so it turns it from here to here. It turns it off, which means it goes from here to here. The resistance resets it until there's a voltage from here to here to turn it back on. And I like to make it that way. And I will show you on a breadboard. So if you take like this, take a transistor in, put that in. That's a NPN. Here's a PNP. You just put them like that, and then cross this one to ground, and then I'm going to create a reset and set. I don't have an AC right now. I only have DC, so it's really good with reset and set and reset, which means it works like a flip-flop. But what you do is it's simpler. Works just like kind of like a flip-flop, but you got to use this resistor as a pull-down ground from the gate. This is going to be the gate right here, which is just like shown here. And then create some jumpers here. But there's going to be another gate. I'm going to substitute a second gate. That's so they both could go to negative as set and reset. And then I'm going to create the power. Oop, there's LED. So what you do is, this is going to be negative. This turns it off when it goes negative. This turns it on when it goes negative. Which means it's on. You gotta turn it off. Like that, see? Isn't that pretty cool? And then when you turn it back on. Come on. And there we go. Turns it back off. There you go. It's working as a transistor right now because you could sense. It senses a small current. That's why this one creates almost 0 ohms. Well, there's always resistance, but it's that wire is probably, I'm assuming, 100 microohms, but I'm not positive. It just, that's why it doesn't really turn on when you turn it back off. And you turn it off. There we go. So that's my circuit, and I hope you enjoyed it. Please subscribe. Thanks for watching. Bye.